Hey class, this is Gigi. In this video, we are going over the antiderivative of basic functions. Okay, so we're going backward. Instead of taking the derivative, we're going backward to find the original function. So if little f of x is sine of x, well, remember, what derivative is sine? Well, the derivative of cosine, we know, is negative sine. So when we go backward, we would say the antiderivative of sine, because it doesn't have a negative, we would say the opposite of cosine of x, and then plus c, because the derivative of c is 0, and the derivative of negative sine is negative of negative, derivative of negative cosine is negative sine, which is positive sine, right? Remember, the derivative of cosine is negative sine. So that is why we have a negative there, because we didn't start out with a negative. And then part B, big F of x, when we go backward, we would ask ourselves, what derivative is 1 over x? And you are right, that would be ln of x plus c, because the derivative of ln of x is 1 over x, and the derivative of c is 0. Okay, so for part C, when we go backward, the derivative of what gives you something x to the 5th? Well, it has to be x to the 6th, so you'll add 1, right? Remember, when we go taking the derivative, we subtracted 1. So that when we go backward and do the antiderivative, we'll have to add 1. But if we only had x to the 6th power and we take the derivative, we would say, well, I would have to take the 6 and put it down here, so that would be 6x to the 5th. But this is 1. So how do we undo that multiplying by 6? Multiplying by 1/6, or we say divide by 6. And then don't forget, you must have the plus c, because the derivative of c is, the derivative of a constant is 0. That c is saying that there are many antiderivatives. C could be 1, 2, 3, 4, 5, whatever you want, pi, e, 2 pi. It's a constant. Now, how do we know what c is? We won't be able to solve for c unless we were given specific conditions about the function. Okay, so here in this example, we are just going backward and find the antiderivative. So we must put a plus c right there at the end. Okay, so next, big F of x is going to equal to, as we know, this is going to have a 7 exponent because the derivative is x to the 6, right? So we have to add 1. And then if we were to go and take the derivative of x to the 7th, we would move this down and multiply. So we would have to now undo that process by dividing. So I would have 5 over 7 x to the 7 plus c. And let's check just to make sure. Move this 7 down, right? 7. Cancel with that 7. I will have 5. X to the 1 less than 7 is 6. And the derivative of a constant is 0. So that's a good answer. Okay, next, the derivative of e to the x we know is e to the x. So when we go backward, all we have is the exact same thing plus c. Because it could have a number at the end, and the derivative of a number, a constant, is 0. So we have to account for that. Okay, now what is the difference between e and f? Well, f of x is e to the 3x. If we were to just leave it as e to the 3x, and we were to take the derivative, the chain rule would have to apply, so it would be e to the 3x multiplied by 3. But I don't have, given this little f of x right there, I don't have the 3. So I have to undo that multiplying by 3 by dividing by 3. So I would have 1/3. Okay, plus c. Now, if we were to check, we would say, hey, then the derivative of f of x is 1/3 e to the 3x multiplied by 3, which is the chain rule, plus the derivative of c is 0. And then this 3 cancel with this 3. I have what I started, so that's a good answer. Okay, then next we would have little f of x. The way it looks right now is weird. And remember that to the -1 exponent is 1 over 1 plus x squared. And that should ring a bell because that is the derivative of inverse tangent of x plus a c, a constant, of course. Okay, now next, let's take a look here. Pause the video and try part H. What must you have had there? So this 1 over x to the 4th, if we were to write it in terms of the power function, that would be x to the -4. Okay, so big F of x is going to be 1 more, right? Remember, when we go backward and when we take the derivative, we subtract 1. So when we take the antiderivative, we add 1. So that would be x to the -3. But if we just had x to the -3, we would have to bring the -3 down. So that would be -3 right here. But we only had 1, so we have to undo that by dividing by 3. So there would be -1 over 3. Okay, let's check. And we say plus c. Let's check to see if that is correct. Bring this exponent down. Negative times a negative is a positive, so that's good. 3 cancel with 3, and that will just give us +1. And then 1 less than -3 is -4. And then the derivative of a constant is 0, so we are good here. So that is the antiderivative of 1 over x to the 4th power. Now, if it's anything other than the negative exponent 1, which would give you either this right here, which is log, or this right here, which is inverse tangent, we could rewrite it as a power function so that we can undo the power rule. Okay, lastly, we have a polynomial. Polynomials are fun because it's actually pretty easy to deal with. To get x squared, we must have started out with x to the 3rd, and then we have to divide out the 3, so that would be 1, plus I would have to start out with x squared. That means I have to undo multiplying by 2, which means dividing by 2, and that is 3 minus 7x plus c. Okay, let's check. Bring the 3 down. That would be 3x to the 2nd. Well, good. Bring the 2 down. 2 times 3 is 6, 6x. And then the derivative of -7x is -7. And the derivative of c is 0. So that is the correct answer. So those are the basic antiderivatives where you didn't have to do anything. You just have to recognize what the derivatives are when we go backward. Okay, so this really is, if you don't know your derivatives yet, you should know it by heart. You should know enough to be able to recognize. For example, this is a hard one right here. 1 over x, the derivative of 1 over x. The derivative of ln of x is 1 over x. So you must know that going forward so that you can go backward. When you have 1 over x, the antiderivative of 1 over x is ln of x plus c.